see you all on our earlier than usual meeting here in November. First of all, any announcements? Anybody got anything they need to share?
Expect a ballot.
Expect the ballot. I did actually have an item in there about the election, but
Okay.
expect the ballot. Anybody want to fill us in on the relocation? Russ, is there anything you need to say about that?
Our deadline now is December
Yeah,
3rd.
deadline is not summer. This, by the way, for those of you, I think everybody knows, but this is the committee that's planning the relocation of Tom Law. So the committee members, mainly Gary and Russ, are in the process of writing a proposal to the Planetary Defense York. I wonder if they picked that because of York. But anyway,
That was,
I wonder if that's part of the,
I think that's the whimsical, yeah.
well, I
Decided.
someone back in the past, I had kind of a temporary job with NASA, and somebody fully seriously gave me the NASA look acronyms.
Yes.
So, anyway, so York is their program for planetary defense grants, and the new submission date is December 3rd. One thing that I thought was excellent bit of news was about Lenny Johnson will sit in on, I guess, some of our meetings, which is a very nice thing since he was the former director of that office. So very good to have his input. I'm looking forward to it. Let's see, what else did I want to one thing I do want to talk about, I actually made this slide before today's news came into play, was we had the holiday party scheduled for December the 7th, which would have been at Snyder's Cabin. We would have brought things like dishes to share ourselves. We hopefully would have worn something, and we would have had some fun. But now I'm not so sure what the status of that is. For those of you that didn't catch that email exchange, the cabin is booked for that day. So what do you all think? Do we want to try to find an alternative venue? Do we want to postpone the party? I know this might be a major breaking precedent, but we can make it a New Year's holiday party, or we can make it a whatever the early February holiday is party, or something of that nature. But I just thought I'd kind of throw that out there as a possibility. The other possibility might be finding another place, which I have absolutely nothing input on that, since I don't really live here in Topeka. I don't know what might be available, but you all think it's worth looking into.
One thing we need to do is have elections, so probably by the end of the year, so that we can start the year with a new slate of people.
Yeah, that is one of the things, and actually that was the next item on my agenda to talk about is election time. I think that the ballots are out or about to go out.
Probably tonight.
Probably tonight. So, yeah, typically the way this works is the ballots go out, people return them, and then the results get dealt with at the holiday party, where one can also vote if so desired. If we don't have a holiday party, what's that going to mean for our election?
I would just set a date sometime, by December 10th, something like that, and just, say all the ballots have to be in by December 10th, and you're voting online anyway most of the time, so, it should be pretty simple.
I would think that would probably be a good way to go. I still want to kind of, if we can come up with an alternative plan, I still think that would be preferable. Of course, that means finding another place.
You can do stuff like, I don't know, I think Perkins still does this, they've got that side room where we can have a dinner, people have to pay for a meal,
Yeah.
but we could have a dinner there, and just if you're gonna order something, anything, at least if it they kind of expect you to order, so.
Yeah, well, that's, and that's, yeah, I mean, I thought about it at a banquet room or something like that. That would probably mean that instead of being sort of potluck like it usually is, it would become a, order off the menu dinner, which, you know.
I don't think they're interested in this shit.
Well,
I don't think they'd allow it.
I have available to me two different places. One is the church that I am a property manager of. I can get that almost for sure.
okay.
Or there is we have a commons room where I live. It has a kitchen. And I'm pretty sure I could probably get that if you want me to look into.
Is that kind of like a central clubhouse or something, or?
Yes,
Yeah,
you know, you go,
we've done that before. We've done something like that before.
there.
Not at that place, but
Oh,
at other places. When Lowell and Nancy, they used to have theirs at their clubhouse.
yeah. Well, see, I live at Martin Creek, and if any of you are familiar with the area around Huntoon and Gate, Huntoon and Fairlawn, there's two real high-rise apartment buildings. Well, there's a drive in between them, and you go in that drive, and you go straight back, and then to your right, you're gonna see, it's basically a two-story apartment building, and the room is in the bottom of that.
Now, does that room have kitchen facilities?
Yes.
Okay.
And,
I'm trying to think, compared to how big it's, oh boy, I don't know.
If you're,
It's big.
compared to Snyder's cabin,
There could be, need 3 Snyder cabinets,
okay.
okay.
or at least 2.
Because I don't think a rattle run is Snyder's cabin, so, you know, we don't need anything too.
But the church is the same way at, you just put everything up in one corner and that's it, so.
I would really like, if this is acceptable with all of you, I would like to stick to the original day if we can, and if you wouldn't mind.
I'll see if I can.
Do you have a preference in order of those two? I mean, one is better than the other, or?
I would feel, my church that I love to now is somewhat of a rougher neighborhood. So I would feel comfortable at, Martin Creek. So I'm gonna see if I'll know by noon tomorrow,
Okay.
whether I can get it, and I send an email out to everybody.
Yeah, maybe, just send it to the board.
Just send it to the board.
Yeah, yeah, I think that sounds like a good alternative plan to be.
Because if I do the church, they'll want some rental money, but if, at where I live, I have a standing $40 deposit check on hand in the pump file that is never gonna cash, so
Okay.
it wouldn't cost us anything.
And that sounds like a little better alternative.
Yeah.
Okay.
Well, as you said, free better.
Okay, so, well, we'll, depending on what we hear from Wes, maybe I will, definitely will send out, a revised announcement on all this with possibly a new venue. So, but we will tentatively plan on going forward on some set, at the usual time.
Yeah.
And, handle it the way we usually do as a potluck, so we plan to bring something. I think we provide, the club provides like cups and eating.
Cups and plates.
Place settings, whatever. Do we provide beverages or do we need drink?
We don't normally provide, I mean, we used to just get tea or something, something like that's tea. But if you want sodas and that sort of thing, probably
Maybe bring some.
bring your own.
That does actually, also make me think of, it seems like in the last couple of years, we have kind of had, at least in my recollection, we would end up with like a lot of desserts one year, and then like a lot of just food. Like last year, we had, a tremendous amount of, food, not dessert. So, I
I
will
will
give
get
you
more desserts, really.
So I'm thinking maybe it might not be a bad idea to kind of have a little bit of a sign up. Maybe we can, I'll send out a message to the club members and kind of.
I try to do what they bring.
Yep.
It's vacuum for you. I think we have decided this year we might try for macaroni and cheese. Specialties, but Gary has his world famous chili. It's the university famous chili. But yeah, I was thinking I would send out some kind of a message to the club members and maybe we can kind of get over the variety and the kinds of things that people run. Okay. Any more on that?
Three Eye Alice actually wanted Gary's chili. That's
Yeah,
why.
that's why I did.
Uh-huh.
That's a message from the aliens.
That's why we have the board.
Yeah, well.
And
We invite forward.
yeah, figure out. I had a social event of the year. So.
Something you could maybe do rather than trying to get people to sign up. I mean, you could do it that way too. You can also try and just split the alphabet. Say, A through G bring main dish, H through something bring
Yeah.
side dish.
I have to get a copy of all of our members' names.
Yeah, you kind of have to do that.
Yeah, which I figure I can do.
Well,
Mm-hmm.
that poses a problem for some of us who can't cook at home.
You can at least buy it.
Yeah. Well, let's. I don't want to, turn this into an assignment. So let's maybe just sort of think in terms of volunteering for now, and then if it forces it over, maybe that would revisit the plan. Okay. So anyway, don't forget again. I just mentioned this, but we're until election time, so hopefully we'll be able to review the results of that. Everybody that wanted to opt out, I think it probably has by now, right? So the ballots are going out. So it might be too late now, but
I mean, you can tell me now.
if you tell us now that you don't want to stand for office, otherwise, it's kind of you get volunteered, so at least to be on the ballot. All right, any other news or announcements? Our new observers, how did you get in
Reagan's the last one to do a solo, and she did okay. We had some, they always need some help, so I usually, what I do for a solo run, I go out to the observatory, they get online, and then they come in and they start working online. The nice part about it is I can write text right on the screen, and they see it.
Yeah,
So I can point things out, I can grab the mouse and kind of point some things out if they get stuck.
yeah.
So it really is pretty helpful. But she got through it okay, so now there's 4 people that can sign up for any particular time on the tomball that's not already on the calendar. So,
I noticed the guys that signed up for World Times Weekend, so hopefully they'll
yeah,
get some good guys.
yeah, and they did it Saturday and Sunday.
I noticed that.
So,
Yeah.
and I'd like to get to the point where we start delineating a little more and saying Sunday from, 7 to 2.
Yeah, that's important, I think.
Yeah.
I actually signed up for Monday and Tuesday because next week is right for us. And I don't know if it's going to be Saturday night, but I figured I would sort of get my word in the water. on
There's
this.
no strife.
Yeah,
Even Saturday night was supposed to be.
Is there kind of-
It's not so much now.
yeah. Unfortunately, that's, next week is a break for us, so I don't know if we can get up with it.
But that's the reason why it's gonna be cloudy and rainy.
Probably is. Anyway, all right, oh, and by the way, we did have a pretty successful open house, last Saturday?
Yes, it seemed like a long time ago, yes.
We had a bunch, I didn't take the head count, we had a very large number of young people out there and seemed to come off okay. We were actually able to demonstrate the recovery of the asteroid 2 inch. I don't know how the impression it made, but it certainly was interesting to me.
That worked out for us.
So thanks to everybody who was involved in that. I think that's the last one of the season, right? The last scheduled public.
Yes.
So we are on public night at AB's until March. So full government. Okay. Anyway, anything else? I also wanted to show some Aurora pictures. Of course, we got a nice Aurora here, which I did not see in person, largely for reasons that we need to. But I thought I'd show a few of these. These are some ones that Parker sent us. This one, Parker, is at your house, right?
Yes.
And then the other two were your son and your
Yeah, the
brother.
one on the top right is my son's out west of Everett, Colorado. And then the bottom is my brother, who lives outside of Moab, Utah.
That's actually a really cool picture. I really love it. I love that area. You know.
That was taken from his house. You'll also recognize that landscape, because if you watch it on John Wayne movie, you'll see John Wayne on his horse being chased by the Indians. And you'll see that background, and if you keep watching the chase, you'll see that in reverse. Where actually they just flip the film to continue the chase.
Well, they went all the way around and came back on the other side.
That is right outside of Arches National Park.
Yeah, that's a fantastic area. I love that area. Grant, there's just a couple that came from Grant.
Yeah, the one on the left is from my dad. On a couple of times. Up in the back is my brother's house in Kansas City, Colorado. And this Colorado was my sister in the opposite direction.
I like this one a lot.
I like all of it.
The green was nice to catch.
Yeah.
Where the green and the red meet in the upper right.
Yeah.
You can see through that, you can see high school.
These are some that Justin sent. These guys, I think, came from Tarpon.
Yeah, they did. He was taking a bunch of images while I was had Reagan on the line, and we were doing the relocation committee meeting at the same time, and he said, "Hey, there's Aurora out here." I said, "I can't. You go shoot it."
That sort of interfered with my moving too, but it's worth it.
That's really the one I got was because I had to leave right away.
Yeah.
Another.
Well, it's been increasing the amount of time in suburbs, which is kind of cut down our ability to go out in the sky. All right, a few news items that I thought were kind of interesting. This is, of course, the one that was occupied a lot of attention lately. It's the Atlas. Broke up into three parts here, but I thought I'd show this.
It's really free out now.
Mm-hmm.
It's three.
Three comma.
And so on the right here is actually a shot that Gary took. This was what through the tunnel.
Food is not below, and it's a combination of about 15 minutes worth of
And this one I think was taken out. This was I'm trying to remember. This came from a news item, but I think this was right after it kind of reappeared around the sun. Right?
I don't know, it looks like it's had some time separated, because I think when you come around the sun, it was pretty hard to tell. At least three, you can see two of them.
Same comments.
No,
This one is the
Is one?
225K one.
Yes, right,
On the
that
left.
was one.
yeah, that, both of them are,
Okay, this one is,
yeah,
they're not 3IS.
no.
several weeks ago.
Yeah.
Early morning, got up,
Could you tell anything on the nucleus?
nothing hadn't broken up yet.
Right. Yeah, that's what I was thinking, because when I shot this one, if I took an individual shot and really, calmed everything down, you could see an elongated nucleus and then another nuclei. So there was probably 3 at that point that was, if you shot short enough, you could see all 3. But because 2 of them are still fairly close together, it just looked like an elongated nucleus was another one outside. So, thank God for all the Elon Musk stuff.
Yeah. just the gift that keeps on giving. Right?
I
A couple of,
watch cat videos.
couple of news items I thought was interesting. This was one that caught my eye because I guess, back when I was an astronomy student in the 80s, we were taught there's 2 populations of stars, population 1, population 2. And the 2s were the old ones, that were all dead now. And then there was supposedly a 3 because the 2s that were still around were not metal rich, but metal rich enough to not be primordial, right? Not to be the first generation stars. Well, it turns out that there were still a few of the, the legendary 3s that are still out there, and they finally got one with the Webb. So these are going to be the first ever stars that form extremely metal.
I was reading some of the details on that. The metallicity of that star being formed is still a little bit hot.
Yeah, so maybe population 4.
Well,
may not be the beginning, but I would
it's
really doubt that.
Well, and where's the transition between 3 and 4? How far back do you have to go before you reach 8-4?
or you find something that's just hydrogen.
And is it right against the wall?
It's
But anyway, this I thought was a pretty interesting story, sort of caught my attention.
Where did you see that?
That was in, I think Physics Today is where I found this one. But I wouldn't swear to it. It might be Sky News. I don't know. It's a really good question. I probably should have recorded that to get proper. One of the things I also thought was interesting on this is one of the members of the team was from Mizzou. So one of the semi-locals was involved in this. I don't know, Parker. Now I can't remember where I found it, but I'll see if I can come up with it. I think I linked to the story just so I can kind of put out and read it in a little more detail later. So I'll see if I can find that. There's another one I thought was interesting. This was actually the radio image these comets. This was done with a radio telescope in South Africa that they call Meerkat, which is a huge array found in this part of South Africa called the Karoo, and it's very remote, so very radio quiet. And they basically built this enormous array out of stuff you could buy at Home Depot, basically, repeated over and over again. So it was stuff. The actual antenna is made out of almost literally common hardware, but in order for it to, it's huge. It's this enormous thing. But the computing array that it takes to actually operate this is just this unbelievable state-of-the-art computer that runs this. So it's this weird juxtaposition. Stuff you might not be able to, live up in your backyard if you have a backyard that was 400 square kilometers. And it's computers that, are just absolutely mind-boggling in their performance. But anyway,
computers to combine all the signals from different.
Right, timing should be,
it's
timing should be just amazingly hard to get all those signals to be timed out.
I've been involved the Green Bank in Mexico observatories. Had in-depth tours, took classes, classes at both sites on radio astronomy, and we got our class got to see the stuff that normal tourists don't get to see. We go back in, look at get to see the supercomputers.
Yeah.
Combine the signals and.
That would be very cool. When I got to graduate school, which I believe was 1986, they had installed they set up the first of the National Center for Supercomputing Applications, so they had this thing called the Cray, which is, it was this weird looking sort of round computer. They used it as a piece of furniture. You could go sit on it if you wanted. And it was this unbelievable state-of-the-art fast machine. And now, I have a piece I could put a computer sitting on my desktop that could blow the doors off of it. Just kind of tells you what. I didn't know what to make of this, but I thought it was cool. Did you guys see this?
Is that real?
I think a lot of people were doubting it, but it is real. So what this guy did was he had a buddy, this skydiver. This guy went up in a powered wing, one of those things that's like a parachute with an engine on it. His buddy took him up, and this guy jumped across and his friend filmed it from the ground through a video with a hydrogen alpha filter, and got this picture, which I thought was just amazing. The most preposterous thing.
Anyway,
yeah, this is real. This is real. And finally, we'll, one more piece of news. This was a legit article, right? This guy actually wrote an article about launching people into the sun. It wasn't really, that's not really what he was, but what the article was actually about was how hard it is to actually launch things into the sun. People talk about that, let's get rid of something by shooting into the sun. And it's also one of the reasons why it's really so hard to get something to like Mercury, right? It's just the way gravity makes it really tough. So, he was saying if we really want to, launch the bad guys into the sun, it's going to be a lot harder to do that than we think. And maybe the better idea is just to launch them together. Just send them out of the solar system. But anyway, so it turns out that launching bad people into the sun is not as good an idea as we might think. Although sometimes especially when I'm impatient with my class, I'm willing to try. Okay, and one more thing I always have to, talk about meteors, because I like meteors a lot. We are headed into, actually, I think it said tonight's, but this was the 19th, so this would have been next before last. The Leonids reached their peak. If you want to see the Leonids, you got to kind of get up pretty early in the morning.
And you gotta be in a different state.
Yeah, and the problem with a lot of it is it's off to the east now, so you're looking out over the city lights. Anyway.
I think I saw one of the Leonids earlier in the week. In fact, it was in the evening, well before midnight, but it came out of the towards from that part of the sky.
Was it 2001 when we had the fantastic display? Is that right?
And there was a nice, really bright one that went completely across the sky.
Nice. Yeah,
A nice green trail.
I saw something the other night. I was coming from Manhattan back to Shawnee, and I had taken 24, and I was just, I don't know if you've ever taken that road. It's just the place where you get to the stop sign just outside of Lawrence, and you got to turn left. And I happened to look up, and something that, so that would have been in the south, and the wind should be in the east, right? It wasn't, Plus, this was like,
well, keep in mind, the direction of travel is what you're looking for, not necessarily the position in the sky, because they'll be coming off the radiant, but they may be in the southern sky when we see them.
This one was probably about 2 weeks ago, too, so if it was wind, it would be all over. Anyway. So I figured since I brought up Leo, I would revisit one of the constellations I talked about once before, but I figured, sometimes you like a sequel, right? So I focused a little bit on Leo, which is not exactly visible until about 1 morning now, but it's going to become more prominent constellation as we head out into the winter and into spring. So thought I'd give a little introduction to it. So it, of course, is one of the constellations of the zodiac, which basically just means that it lies along the plane that most of the stuff in the solar system, including the Earth, orbits the sun in the plane of the ecliptic. And if you want to find it, it's actually very faint, but right now it's pretty much to the east of us, but it's not going to rise until sometime after about 1 in the morning when I check things. So it's going to be one that you're going to have to be dedicated to get up and see. As far as the story goes, I didn't really realize that there was actually a mythological connection to this one. You know, I always kind of think about the mythological connections and try to talk a little bit about it when I do these little constellation things. And I really never could see how Leo actually fit into all this, but I had this big book of mythology I had to buy as an undergraduate, and every once in a while I take it off the shelf and kind of thumb through it. Turns out there is a story to it. And the story has to do with another mythological figure, Heracles or Hercules. And turns out that the myth in this case, the thing that ended up with Leo being enshrined in the night sky, was related to Heracles. So the Leo actually represents what was called the Nemean lion, which was a lion that was exceptionally fierce. The Nemean lion's fur was impervious to any kind of damage. It was golden fur, which is one of the reasons why many people try to hunt it and all pretty much ended up dead. Its claws were able to defeat any armor, any protection. So this was a very formidable animal. And you may wonder why Heracles decided to take this thing on. Well, again, that's a story that probably you may know, at least a little piece of it. So Heracles was the son of Zeus and a mortal woman named Alcmene. As we've talked about many times now, the pantheon of gods here were exceptionally poorly behaved entities, and Zeus was probably the worst of the bunch. So Zeus was married, of course, to a goddess, but was kind of noted for his philandering. And one of his philandering partners was this woman, Alcmene, who ended up being mother of Heracles. Of course, Heracles was married to Hera, or Zeus was married to Hera, who is kind of like the goddess of pastorality and peace and harmony, and is not at all like that in real life. She was in the mythological set a very angry, vengeful, and generally sort of unpleasant woman who was very upset with Zeus for his philandering, which, since he was pretty much a non-stop philanderer, she was probably unhappy much of the time. And she hated Heracles, even though he in a sense was named after her. The name Heracles was chosen to honor her, which I think on Zeus' part was a pretty stupid thing to do. It's just like fan in flames, but at any rate, she did not like Heracles at all, and was trying to get rid of him almost from birth. In fact, at birth, she put snakes in his, or shortly after he was born, she put snakes in his crib, essentially, to try to off Heracles. Unfortunately, Heracles, who, of course, is now associated with strength and vitality, was able to, even as an infant, was able to kill these snakes with his bare hands, so he foiled that one. Eventually, though, Hera had on a plan that would actually work. Heracles actually was married, had a family, and Hera figured out a way to drive him mad, basically used drugs and earth magic to drive him mad, to make him delirious, and in that delirium, he murdered his family, killed his wife and his children. This, of course, was not particularly good behavior, so Heracles had to present himself to the Oracle of Delphi, which was a seer, right, a woman who basically had mystical powers. And the Oracle said that if Heracles could complete 12 labors, he could essentially redeem himself for having committed this murder. So even though he did it more or less involuntarily while he was under the influence of Hera, he undertook the 12 labors. So that's where the 12 labors of Hercules or the 12 labors of Heracles comes into play. A lot of these labors involved fighting mythical beasts. You fought the Hydra, right, which is a creature that had snake hair and could turn into stone. If you looked at it, it was really nice, and you fought that one by looking at a reflection in his shield and fighting that way. But the Nemean lion was actually the first of his labors. So he went out to slay the Nemean lion. Of course, again, Hercules was noted for his strength and his ability as a warrior. Pretty tough matchup, though. What he ended up doing actually was cornering the lion in a cave. He sealed up one entrance of the cave, cut off the light. Right, that actually made it difficult for the cat to fight because it had to rely on his vision. And he was able, through sheer strength, to subdue the beast. And he went on to complete his 12 labors and relieved himself in the eyes of the gods. Actually became a god later. Got remarried, more or less a happy ending, although certainly not happy for his person at all. And the Nemean beast was, the lion was enshrined in the heavens, and that's the origin of at least the Greco-Roman origins of that constellation. Like most of these, probably there's actually stories that go back into Babylonian times about this, which kind of, tells us something about the nature of these constellations. They probably got handed down through more than one culture. The lion sort of remains, right? If you've ever seen an Indian movie, especially some of the older ones where the lion roars at the beginning, that lion was named Liam, was a lion, I believe, in the Los Angeles Zoo. At least the original Leo. So if you see older Indian movies, you see that roaring lion. I think now they use a more animated one. They didn't do it at all. That's an Indian movie. I assume Indian is still around, but anyway. So it's kind of made it into the culture as a registered trademark. Yes, but that's the story. And again, if you want to see the layout of meteor showers, meteors, of course, are just debris usually left over from some small body, a lot of times just comet, sometimes a minor planet. We get these meteors occur when the Earth kind of intersects these things kind of lead. Someone once described it as, I don't know if you remember the Peanuts cartoons, they described these things as being a little bit like Pigpen, the boy that was always kind of leaving a trail of cloudy dirt behind him. That somebody once compared the passing comet to that, and when the Earth passes through that stream of stuff, all the little pieces come into the atmosphere and heat up, and they form these meteors. So when you look up, you're seeing those. I was really amazed to learn how small those things actually are. They're like grains of sand. A big one might be like the size of a pea. And a really big one, when it actually kind of becomes like a bowl, it actually explodes. They may be about this size. So I was really amazed to actually learn that. And if you want to see him, you're going to have to get up you're going to have to stay up pretty late. So I captured this off of, whatever that program is, Solari. At, I guess it'd be 1:16 tomorrow morning, you're going to be able to see this. But it's going to be off in the east, kind of northeast, which for most of the places is going to be kind of lost in a lot of the straggling city. So if you really want to see them, that's the time and the place. Okay, so, and now I have the pleasure of introducing someone I think most of you probably already know. I certainly was not here for the last presentation, but watched it and was quite interested. So let me introduce David Culp, who's going to talk about Cecilia Payne-Gaposchkin, who is one of the most significant astronomers in the history of the sun. So, David. I can get this out of the way. And you want to speak? Or
probably just here. Still is. Let's do that. This is a repeat of a presentation that I gave the Strongly Associates of Lawrence earlier this fall. This is also the laptop I use for my imaging. Okay, switch to this is
Might be a resolution issue, I'm not sure. Um,
let's see. I'm not picking up this thing for some reason.
oh.
Maybe the size of the first one. Yeah, well, that probably would get motivated.
Here.
Yeah, this,
That's so nice stuff.
Yeah,
Oh,
sure.
flash disk over there.
lower left.
This is G.
Okay.
Is this the presentation mode?
Control L, or
Do what?
Control L, maybe. Full screen mode there, view. Full screen mode.
See the screen hold up. Full screen mode. Try to do this. Okay. So much for that. My laptop worked here before once.
Yeah.
Yeah.
Well, I think it took a half hour for my business to get it to work.
Not too long.
Okay, this is the 100th anniversary of Cecilia Payne's discovery of the composition of the stars. I'm going to talk about a little bit about her life story, which led up to her discovery. And let's start with childhood. She was born in Wendover, England on May 10th, 1900. Middle-class parents, Edward Payne. Her father died when she was very young, when she was just a few years old, a couple years old, and was raised by her mother, and she also had an older brother, Humphrey. She attended a private school run by a woman by the name of Elizabeth Edwards, where she learned French and Latin, and also geometry, algebra. She's very good at mathematics. And she had an early passion for science, particularly botany. And she was known for doing a lot of botanical drawings in her youth. Well, as she and her brother got older, her mother moved to London so that Humphrey could receive a better education. Her mother enrolled her in St. Mary's Catholic School, which was not a school designed to give young girls an education in science or math. However, despite the limited science instruction, she always carried away the top prizes in school. She did get some tutoring on the side in mathematics and some of the sciences and chemistry. She was not at all happy. She did not like particularly going to mass, and she tried one time to convince a local book binder to take a science book and bind it put it in the binding of the Bible to try and sneak it into mass so she could read science during mass. The school really didn't know what to do with her. She was very not very non-compliant, and they ended up expelling her. They just could not handle a high-achieving child. Her mother then enrolled her into St. Paul's Girls' School. And this had a very strong science curriculum, biology, chemistry, and physics. She became a member of the orchestra and learned to conduct under Gustav Holst. In just a couple of years, she got taught in chemistry, Newtonian dynamics, thermodynamics, electricity, magnetism, and basic astronomy. So I think just a year and a half time. Very short. She's extremely, this indicated she's extremely bright to be able to catch up on all that science in such a short time. Now, she went to a, she ended up, during this time, physics replaced her love of botany. And she attended the school 1 year before going on to Cambridge. And at Cambridge, she was enrolled in Newnham College, which is their college for women. And she was enrolled in 1919. She studied in the Cavendish Library under Charles Cyril, Niels Bohr, and Ernest Rutherford. And this was a very sexist environment. Let me grab a little something here. Give you a little flavor of what kind of what she endured. This is a biography of Cecilia Van Gushton by Donovan Moore, and in a foreword by Jocelyn Bell, she describes her time at, where was it, the University of Glasgow. When she said, when I was a undergraduate at the University of Glasgow in the 1960s, everyone in the sciences in the lecture theater to aid in taking attendance. Inevitably, women were placed in the front row. When we entered the theater, we were often greeted by whistles, catcalls, and the thumping of desks and the stomping of feet by the male students. 40 years earlier, Ernest Rutherford's classes at the University of Cambridge, Cecilia Payne also sat in the front row, and she faced similar attention. So that's the kind of environment she was trying to deal with. We had to learn to deal with it. Now, about this 1919, at the end, this is, remember, the famous solar eclipse, where Eddington observed stellar deflection of stellar starlight by the sun's gravity. Well, Cecilia attended a lecture by Sir Arthur Eddington, and this caught her attention, and her attention then turned towards astronomy, where she then started working in the Cambridge Observatory, where she then studied under Sir Arthur Eddington, W.M. Smart, and E.A. Milne. Here she learned about relativity, celestial mechanics, reduction of observations, and the chemical compositions of the stars. Now, at this time, Eddington and other astronomers believed that the uniformity of composition, believed in the uniformity of celestial bodies, that all of them start the same composition as the Earth. So if you take a chunk of piece of the Earth, heat it up extremely hot, the spectra that it would produce would be very similar to the Sun. And they believed that the Earth, planets, and stars were all the same composition as the Earth. And but during this time, they also realized, when you look at the spectrum of stars, say a hot B5 star versus a cooler G4 star, they realized at the time that the appearance of the spectrum had to do with temperature. But the mechanism wasn't well understood. Now, after when she completed her studies, her options were basically one was becoming a school mom, because Newnham College did not actually confer degrees. So it was a dead end. The UK was a dead end for her academically and intellectually. During her last year there, she attended a lecture by Harlow Shapley while he was visiting the UK, and was inspired to go to America, where her prospects looked better. Now, in 1920, Meghna Sahib, an Indian astronomer, developed a theory using quantum mechanics and statistical mechanics that explains the appearance of a star's spectra in terms of the temperature and pressure of the star's atmosphere. And Melanie encouraged Cecilia to test us there using the Harvard Observatory Library of Stellar Spectra. See if this uniformity in the composition of the stars and other planets and such could be verified. Now, one of the advantages of Cecilia's education is that she got a good background in quantum mechanics, statistical mechanics, which gave her the tools to tackle the stellar spectrum library at Harvard and to try to apply Saha's theory to those spectra. Now, she joined the large number of women employed at the Harvard College Observatory. And, of course, these women were all grossly underpaid. Before Harlan Shapley was the director, the previous director, what's his name? Something in my tongue. Pickering. The women at the Harvard College Observatory were often referred to as Pickering's harem. So, again, sexism was still pretty prominent at this time. Now, these women classified stars according to the appearance of their spectra, the common OBJKM classification scheme that we know today. But the physical basis at the time was not known. So Cecilia enrolled as a graduate student in Radcliffe College, Harvard's Women's College, and she began the analysis of the spectra of high stars. Now, she struggled with these spectra. She was not trained as a spectroscopist. She spent nearly 2 years trying to make sense of these spectra. And after 2 years of struggling, she made a breakthrough with the element silicon. And her quantum mechanics knowledge, Saha's theory, knowledge of Saha's theory. This is Saha's theory in quantum mechanics. Gives the relative number of atoms in two ionization states. It's a function of electron density and temperature. And she used this information. She used this information to determine the composition of stars. Now, she showed that the composition was fairly uniform, as had been said, with the exception of hydrogen and helium. Now, Saha's theory, Saha is shown here in the middle. Equation on the left is the Saha equation, and it basically relates the numbers of, say, of an ionized atom to the next, to the say maybe a neutral atom, or ionized hydrogen and neutral hydrogen. This is electron density. These are some statistical mechanics weighting functions, and this is the energy of those ions. This graph shows what the strength of the different absorption lines look like versus spectral type. So like hydrogen is fairly faint in hot OB type stars. It peaks, it's extremely prominent in O type stars, then it tapers off. Cooler stars. Cooler stars have very strong lines of calcium. If you've ever observed the solar spectrum, you'll notice that on the blue end of the spectrum, there are two very prominent calcium lines, which some of you read about here. They get even stronger in cooler stars. And you can see, here's a list, a display of different spectral types. Cool stars, you can see the KH lines of calcium, how they disappear in hotter stars, and we can see how the hydrogen lines get stronger in A-type stars, and then And what Cecilia did was she basically determined the ratios of these ions for the different elements. And this is a excerpt from her thesis. This is the use of the observed line strengths that she saw in the spectrum versus the predicted line strengths from the Saha theory. So she compared she took the observed line, took the observations, compared them to the theory, and was able to deduce the abundances. So she would determine the ratio of the ions for hydrogen and ratio of, say, the ions for calcium. And by taking the ratio of those ratios, she could determine the relative abundances of those elements. And it turned out that hydrogen was about 1 million times more abundant than the amount than other elements. Helium was about 1,000 times more abundant. And this was in complete fluid, the opposite of what the astronomers thought at the time. And so her, let me go on to the next slide. One of her thesis advisors, Henry Norris Russell, said, "This is absolutely wrong. This can't be right." And he made her insert this little statement into her thesis. The outstanding discrepancies between the astrophysical and terrestrial abundance are displayed for hydrogen and helium. The enormous abundance derived from these elements in the stellar atmosphere is almost certainly not real. So, Henry Norris Russell had her insert that into her thesis.
Was he questioning her methodology on the ratios or what?
He just believed that the results were wrong. And he just could not believe that was correct. But everything else, to them, they looked at the results of all the other elements, and they were in agreement with what they expected, except for hydrogen and helium. So her thesis was published in 1925. She refers to the first PhD from Harvard. 650 copies of her thesis were printed. We know this because Harlow Shapley kept every one of his correspondences, just about every paper he has in the Harvard archives, several rows of boxes, just dozens and dozens of boxes of papers that were archived. And in one of the boxes of letters, he says 650. We printed 650 copies. So they know the actual number printed. Now, Henry Norris Russell finally came around 4 years later and said, okay, your results were correct. He used an independent method to came up with the same results. But if you look at history basically gave him all the credit. Since he was a much more prominent figure in astronomy, his results from 4 years later received all the credit. Cecilia was basically ignored. Here is the title page to her thesis. And this was described by Alice Grove as the most brilliant PhD thesis ever written in astronomy. You can see her signature on the title page. The signature up the top is Norman Storer, the chairman of the KU Physics Department during the 1930s and 40s. Okay. This is his copy, which is in my library now.
He actually, Storer was actually in charge, I think, of the 27-inch
Yes. Yes. And it was under his direction that Clyde Tombaugh
Yeah.
worked on it.
It's still quite a difficult process there. They do it to get
After her degree at Radcliffe or Harvard, she continued working at the Harvard Observatory without a title. At the time, Harvard President Lawrence Lowell, and his personal goals, that's his brother, said Miss Payne should never receive a position in the university while alive. When Harlow Shapley kept deflecting other career opportunities away, trying to keep her there. In 1934, she married Sergei Gokshin, a Russian astronomer. And in 1934, she received the first recipient of the Andy Cannon Prize from the American Astronomical Society. She specialized in the study of variable stars. After Shapley retired, the director was replaced with Donald Menzel, who doubled Cecilia's salary. And in 1956, she became the first woman to be promoted to a full professorship at Harvard, followed by the first woman to chair a department a few months later. She chaired the astronomy department. In 1961, she received the Rittenhouse Medal from the Franklin Institute. In 1962, her last PhD student was Owen Dandridge. Owen Dandridge had a copy of her thesis, which was also signed. He gave it away to one of his students. In fact, Owen was last year, was 2 years to die. 2 years to die. And a lot of his library went to the dumpster. The really good stuff went to Christie's auction house. And in 1976, she was the first woman to receive the Henry Norris Russell Prize from the American Astronomical Society. And in 1979, she passed away after that with lung cancer. She was known as a chain smoker. She literally would light the next cigarette from the butt of a previous cigarette. And my friend Steve Shull can attest to that.
Been there, done that.
Other books by Cecilia Payne is the Stars of High Luminosity, Variable Stars and Galactic Structure, Introduction to Astronomy, and Galactic Nova. Early. More recent acknowledgments. She's been getting more acknowledgments in the last 20 years. And if you go out on the web, you'll find a lot of information about her now that wasn't there before. In 2008, the Institute of Physics, that is the UK institution, gave her the named a prize in her honor, the Institute of Physics Payne Adoption Medal. 2014, she was featured in an episode 8 of the Cosmos series that aired on Fox Television. The book that I have in my library, her book, was actually used by the production company to in the filming of that episode. They did come. They were in 2013. They were looking for a copy of the book to feature in their episode, and they found a reference on my website, and they also were contacting Harvard, and I responded first. So, if you watch episode 8, on the very last screen of the credits, you'll see my name posted there. 2018, the American Physical Society's Doctoral Dissertation Award in Astrophysics was reading the Cecilia Payne Adoption Doctoral Dissertation Award. And she also is the namesake of one of the ASAS SM. This is it's a supernova survey. I forgot what the acronym stands for. The last two characters are Supernova, I forgot what the first four stood for.
All Sky Automated? All Sky Automated Survey.
Yeah, also automated survey for Supernova. Born in South Africa, so her name, she's named after one of the scopes is named after her. And she's also the namesake of the famed option of Tira volcano on Venus. No references. Questions?
Do you know if she had any connection with Henrietta Love?
No.
No connection.
I think Henrietta Love had already passed away.
There was a big time between, I thought maybe in Henrietta Love's older
She
time.
had Henrietta Love's office space.
Okay, there you go. There's a connection.
She did have her office space. She did take her office space. If I remember right.
Questions?
How did you get the book?
I found it in
Dissertation?
the bookshop in Lawrence, Hood Books. They're on Mass Street.
Okay.
It's like 1986. Or 85. I walk in there and I'm looking through in the back of the store, and in the science physics section, there is all of these books from Storer's library. Basically, John Hood bought up Storer's library. And it was just crammed full of his books, and this was one of them. I recognized the name right away. And, this is a treasure. $20. I'm a starting graduate student. $20 is a lot of money for me at that time. But I emptied my wallet and bought the book.
Storer was Clyde Tombaugh studied astronomy in the Storer.
Yes.
The Storer would jokingly say that, of course, all that was well after he discovered the
Yep. Oh, Rick Heschmeyer, several years ago, stumbled across a recording that Storer made.
I had that.
You have it?
I had it.
Did you get it from Rick?
I did.
Okay.
Yeah, I shared it with my brother. He was a fine gentleman, and we just did just about anything for you. When I was in high school, he had my brother and me come over on weekends, and he tutored us on the telescopes, and then he would get us started, and then he could do what he was going to do, and let us be out there most of the night. But I went to KU, and then gradually I was a chemistry and math major. Of course, it was a astronomy guy, but he said, hey, I can do this. So, he became my advisor.
Okay.
Questions? I think one of the, I don't know if you remember, but a couple months ago we had a presentation on the exoplanet transits. You know, the telescope that that day became was also constituted, and I believe it's after.
Ooh, interesting.
That was in Arizona.
Is that Mount Hopkins with us?
I think that is where they are. They're associated with Gregville. Yeah. It's one of those automated coaches they've set up to capture exoplanet transits. Yeah. All right. Well, thank you, Dave, for coming over, and we certainly appreciate it. So, what was I going to say? Yeah, I'll get it back to you all when I find out more from Wes about a potential interview. Heard to me that their office is closed tomorrow, but I'll know no later than Monday evening. Okay. Well, whenever information becomes available, that'd be great. I think it's okay. So our next regular meeting will be in January, right? And, anybody want to do a presentation? I always ask.
I've got a presentation on my library.
I think I got one that I would want to do. Actually, I've got a two-parter in mind, but would you consider coming back maybe sometime in spring?
Sure.
I actually kind of have a.
What's that?
Presentation on the library. Just have some.
Easy to receive, headed down for the summer session. Yeah, that was a number of years ago. That was during the pandemic. I've added quite a bit to that library in recent years since then. In fact, I've turned my house into an art gallery. It's lined, the walls are lined with 17th and 18th century prints. You know, the originals, not reproductions, the original prints. If you're familiar with like the Andre Solaris Atlas, I have several of the highly sought after Andre Solaris prints.
Yeah, those are pretty.
There's a presentation I've been working on a little bit, and I don't feel qualified, you should like to see some of those
Oh,
on title construction enhanced
title construction units?
TEDs,
Well,
ESAS, reminding me that somebody was against our of ESAS, artists.
mm-hmm.
So far, well, as far as I can tell, all of them sort of did other galaxies. And they did a study of all that remote galaxies. I think it's an interesting topic. I just, I keep walking through, wading through that.
I can sympathize with that.
I have another presentation I'm working on. I haven't actually written it up, but I've done the research as far as I can take it at the moment. There was an astronomer who was actually from Florence from the 19th century who grabbed headlines around the world, and she refused when she stepped down from her position at Smith College after Smith College accepted money from the Carnegie Foundation.
That was considered tainted.
She considered that money tainted. And
Well, looking at it from this end of the thing, it's like there's no such thing as tainted money.
it's all tainted.
It's all tainted.
Why was it tainted?
Well, in the late 19th century, the robber barons is considered, it was Carnegie was one of the robber barons.
I see.
And the church she belonged to, a lot of other churches thought that the money that they made was ill-gotten gain, tainted. And her father was a congregational minister and was a lot of folks operated one of the underground railroad safe houses just outside Lawrence. And there's a uncle was one of the first congressman from Kansas after Kansas obtained statehood.
One of the first grants I ever got was from the Ford Foundation, which I guess is the auto study. So I guess you could consider that one to be slightly tainted.
Yeah.
I've never felt compelled to buy a Ford, but it's nice to have one.
But I've done a lot of research on it. She's buried in Lawrence. And I asked I asked people around Lawrence if they had ever heard of her. No one had ever heard of her.
Who's this?
Mary Emma Bird. I have found records where she was using the the 27, well, not the 20, but using the KD observatory, I think probably with the Clark refractor at the time.